problems happen when you start the recording?
It does have something to do with the recording because the recording uses like 60% of the memory and 49% of the CPU, or other way around, 60% of the CPU and 49% of the working memory. But the problem is, on my old machine, it didn't do that because my old machine was actually a laptop, not this thing. Right? Great. So we will start with the real number system is our, and when I say our, I mean the one that we use today. It is not the only number system in the world. It is not the only number system that has ever been used. It is the one we have chosen to use now. And that number system is the real number system. It is based on 10 digits, 0 to 9. It's becoming slowly obsolete because computers don't use it. Computers do everything in binary, 1 and 0.
There's also trinary.
And yeah, for the computers that anybody actually uses and do anything in real life, it's all binary. Yes, there are quantum computers, but they will not come into play into your people's lives, really, ever. They're experimental. And they're going to cost so much money that nobody is ever going to use them for any sort of large capacity thing. I'll give you an example of computer technology, just for fun. In 1973, the first digital watch was made available on the open market. None of you even wear a watch right now. But if you did, and you were wearing, say, a Timex, and it was a digital watch, how much would it cost?
$20.
You can get a watch for $10, a digital watch for $10. There you go. The first digital watch available on the open market in 1973, take a guess at how much it cost.
$1,000.
How much? $2,100. And it was called the Pulsar Time Computer. $2,100. Now, just to put that into perspective, a brand new Ford Pinto in 1973. Now, the Ford Pinto is a piece of crap car that exploded if it got rear-ended. But it was Ford's, it's true, it was Ford's version, it was the 1970s version of the Ford Focus, like the lowest end Ford you could get. A new, straight from the car lot Ford Focus Ford Pinto in 1973 cost less than the Pulsar Time Computer. So that just to show you where computing technology has been in the past and where it is going now. Now, back to what I was saying. Yes, Eric?
I paid $70 for my Pinto.
Wonderful. Our number system is based on 0 to 9. 10 digits. When you get to the number 10, that is an entire one group of all 10 digits and 0 left over. That's what 10 means. Everybody knows this. At least I hope you do. The real number system is broken down into a few categories. And like I say, those categories are important when you're depending on what you're using the numbers for. So we're going to start with the natural numbers. Now, the natural numbers are the smallest group of numbers. And in a second, you're going to see that when I say the smallest group of numbers, it's a pretty big group of numbers. If I were to say to all of you, let's go back to kindergarten with Mrs. Bad Crumble, and let's pretend that she had a big stack of, chocolate chips on her desk. Well, no, when you guys were in kindergarten, they wouldn't have been able to give you chocolate because that would have been candy and that wouldn't have been allowed. You also couldn't have had peanuts. So she had a pile of Lego pieces on her desk. And she said, I hope nobody's walking around barefoot. Yes.
No, I hope someone you hated stuff on.
What?
I hope someone you hated stuff on.
No, I would never wish stepping on Lego on anyone. That is one of the worst tortures that could happen to a first world person. Stepping on Lego is horribly painful. The
Can you actually watch the world longest Lego walk and actually get a world record for it?
Okay, we're going to do this. Everybody that wants to talk about horse crap, go to the back of the room. Get up.
You can't talk about
Everybody that wants to talk about, go to horse crap, go to the back of the room. Everybody that wants to finish this lesson so you can actually talk about horse crap so I can be done, can come up to the front.
I'm already in the back.
Kind of lost on him, eh? I know, right? If I asked you to count the pile of Legos and I said, let's all count them together, class, how would you start?
Take one and put it away. 1, 2, 3.
Excellent. So what is the first number you all started with?
1.
1. Is 1 the first number? No, of course not. So the natural numbers are what we use when I say, let's count. They are our counting numbers. And as you all just demonstrated, when I said, let's count, you all started with 1. And then you went 2, and then you went 3. And when could we stop counting? When there's nothing left to count. Or, what is the last number I could count? It is a long list. What's the last number of it? Infinity. Is infinity really a number? No, it's a concept. But for lack of a better word, we say it goes up to infinity. All right? Now remember, I said that's the smallest group of numbers, and it has an infinite amount of numbers in it. Everybody cool? All right. Next on the list is whole numbers. Now, you guys have heard the term whole numbers before, and you know that it means numbers without fractions. That's part of it. What it really is yes, numbers without fractions, but they are the naturals plus 0. So it is 0, 1, 2, 3, up to infinity. Does everybody understand why natural wholes are slightly bigger set than naturals? Exactly one number bigger, 0. Everybody cool? All right. And it's a bit of a weird concept, right? Because 0 is our number for nothing. And yet, it is a thing. Okay? Which is kind of why the number 0 wasn't even invented until like the year 700. Next. Have I used yellow yet? I did. Curses. Green. Integers. Integers are the naturals plus the wholes plus the negatives. Negatives. So they go negative infinity, dot, dot, dot. We won't do dot, dot, dot. Up to negative 1, 0, 1, up to positive infinity. Everybody cool? Now, we need to talk about these numbers a little bit here. What do you notice that I did not write in any of these? I wrote no fraction, I wrote no decimals, right? Because when you're doing natural numbers, let's count, 1, 2, 3, you don't ever use fractions. As a matter of fact, you never even thought about fractions until you were about 4 or 5 and you weren't doing what your mom told you to do. And your mom said, go to your room. And you said, no. And your mom said, go to your room. And you said, no. And then your mom said, 1? And you went, what the heck is this? And because it was new, you went to your room. 2 or 3 times later, your mom said, go to your room. You said, no. Go to your room. No. 1. No. And your mom went, 2. Holy crap. And you ran to your room.
What's going on?
Because you were scared to death of what might happen.
What is this sort
Of course, now you know that it's the 21st century and your mom could count to infinity and never do a thing to you. Because it's the 21st century and nobody actually gets punished anymore. So, but you were scared of what might happen if your mom got to 3.
What is this sort of surreal?
But your mom didn't know what she was going to do if she got to 3. So your mom all of a sudden introduced you to fractions. 2? No. 2.5? What the hell is this half? And if your mom was really good at math, she could actually count to infinity before she ever got to 3, couldn't she? 2 3/4, 2 7/8, 2 15/16, 2 31/32, 2 63/64. And then you were like, ah. So all of us, that is really why fractions scare you people. Because until you're either getting in trouble or grade 3 when you started doing fractions, you thought that it just went 1, 2, 3, 4. And then all of a sudden you find out on that number line that Mrs. Bad Crumble had in her room that between 2 and 3, there's actually another infinity. And then all of a sudden you're like, math's hard. So, since I have not talked about fractions at all yet, what's coming up? Fractions. Now, the more astute members of the class will recognize that word, which is what? Ratio. Rational ratio. That means these guys are our fractions. But there's some rules, okay? 1, you have to remember, everything up there is rational. So if you're natural, you're rational. If you're whole, you're rational. If you're an integer, you're rational. It's automatic. Because all of these numbers can be written as number over 1. Right? 7 is really 7 over 1. Everybody cool with that? We know that already, right? Okay. That's the first rule you got to remember. The second rule, fractions, technically, to be a rational number, must be written like this. X over y. Some number over another number, x and y are integers, and y cannot equal 0. Everybody cool with that? So anytime you see numbers written this way, as long as the top one is a rational number, or an integer, and the bottom number is an integer, and y is not 0, you have a rational number. Everybody cool? Now, what are fractions' ugly cousins? Decimals. Since decimals are very closely related to fractions, decimals must be included in any discussion of rational numbers. But decimals cause us a bit of grief. And here is why. And I'm writing it in red because it's a bit of a different path.
It's a warning.
Decimals can be in two different ways. One, the decimal ends. For example, 0.537. There's no more numbers. So it's ended. That is rational. Because that is really 537 over 1,000. Right? 537 thousandths. We're all good with that, yeah? But there's a problem with this even. Because what happens when I do, is what I'm about to write a rational number? Yeah, why?
0.75.
No, that's 1, 3.
It goes to 0.75.
No, it doesn't.
0.3.
No. Guys, stop.
0.20.
Stop thinking about decimals. Is that a rational number?
Yes.
Why?
Because
Because it's got a 1, and 1's an integer, and it's got a 3, and 3's an integer, which means that has to be a rational number, yes? What math is happening there? That is 1 divided by 3, correct? What does that give me as a decimal? No. 0.3333 for how long? Ever. So when we're dealing with decimals, it's not enough to just talk about the fraction side of things. We also have to add in this rule. If the decimal ends, it's rational. If the decimal repeats, it's rational. Is everybody cool? Okay. Now, being the intelligent members of society that you all are, if there are rational numbers, there must be irrational numbers. What must they be?
You're being irrational.
Yeah, they are irrational. Why?
Because they're not rational.
Okay, so what would make a number not rational?
It's something can point a whole bunch of different numbers that have no distinct pattern.
Excellent. As a decimal, they neither end nor repeat. So irrational numbers are only decimals. Can I have an irrational number that's written like this? No. Decimals that neither end nor repeat. And what is the most famous one? Pi. And pi bothers people. Why? What is pi?
It's something you eat.
There's a bunch of numbers that are not repeated.
How do we get pi? How did we get that number? 3.14159 blah.
A whole bunch of calculations on a certain
No.
Pi button.
What is pi?
Who knows?
a number.
It's Greek. I think that's one of the things.
Yeah. How did we get the number pi? Interesting. It is the circumference divided by the diameter. Now, when I write it that way, doesn't it appear that pi should be a rational number? It looks like the circumference will be a number and the diameter will be a number, won't it? But what we find out is if you draw any circle, if you draw it to a certain diameter, the circumference will never be an integer. It will always have a decimal. If you draw a certain circumference and then measure that diameter, it will always be a decimal, which is not an integer. So never does pi actually get to be integer over integer. Is everybody cool? That's why pi, even though it looks rational, isn't. Yes.
It feels left out because it can't be an integer or rational number.
Okay.
It feels left out.
You know I don't tell stories like that. Numbers don't have feelings. They're just numbers.
Are you numberist?
All right, yes. I am incredibly numberist. Yes. All right. Does anybody know of any other irrational numbers? There's a bunch of famous ones, but you guys won't have studied any of them. But I'm just wondering if anybody knows of any.
Oh.
No? Okay. But there are some that you do know of. What is the square root of 1? 1. Good. What is the square root of 4? 2. Excellent. What is the square root of 9? 3. Excellent. Please notice that the square roots,
Please notice that your computer has set it freeze.
the square roots are all our integers, aren't they? They're all natural numbers, yeah? But what do you notice about those guys? There's no pattern, is there? There actually is a bit of a pattern, but something's missing, isn't there? Right? 1, 2, 3, 4, 5. We could go on forever down the right side, right? But on the left side, there's going to be missing stuff, yeah? What is missing? What about the square root of 2? What about the square root of 3? What about the square root of 5? Square root of 6? Square root of 7? Square root of 8? What are all of them? A crazy decimal, yes? Those guys are, for your purposes, the irrational numbers. anytime you see this symbol and it doesn't work out, you have an irrational number. All right? Everybody with me? Now, sometimes it's going to be tricky, right? Because everybody is good at the perfect ones, right? What's square root of 16? 4. Easy peasy. What's square root of 25?
5.
Excellent. What's square root of 225? 15. Right? We're all good at that, right? Some better than others. Well, she probably listened to her grade 9 teacher who said you should memorize the first 20 square roots. Okay. Well, then it's not memorized, is it? Right? By definition, it's not memorized if it's forgotten. Psh, Mr. Myers. God, don't throw English in my face. This is math class.
Don't be silly.
All right, so sometimes, though, something is a rational number that doesn't look like it's going to be. For example, do you think the square root of 12.25 is a rational number? Don't go to your calculators. Do you think it is? Because all these are nice and perfect, right? But that is a perfect square. If you go to your calculator, you will find out that it is 3.5.
Whoa. Mind blown.
That's a rational number. Okay? So even sometimes, even when it looks like, oh, it's a decimal, it can't possibly have a square root. Sometimes it does. It's just not a perfect square. Everybody cool? All right. So let us move on, cabbages. I'm going to ask you to do 4 things that you learned how to do in the 5th grade. I want to see who can remember it. Start with 1A, because everybody can do that one in their sleep. At least you should be able to. Make that decimal a fraction. I will tell you right now, all of you can probably do it right away, but remember, there's more than one way to write fractions. So go. What's the first one? 12 over 100. Is that acceptable?
No.
It's acceptable. It's 12 100ths, right? Perfectly acceptable. Would Mrs. Bad Crumble like it? What would Mrs. Bad Crumble want to see?
3 over 25.
She'd want to see 3 over 25. However, from my perspective, I need you to be aware that they are the same thing. 3 divided by 25 is 0.12. 12 divided by 100 is 0.12. 24 divided by 200 is 0.12. 48 divided by 400 is 0.12. Everybody with me? All right. Now, look at B because it's slightly different. Let's think about it for a moment. Some of you may already know this trick. Please don't say it out loud and give it away. How do I turn that to a fraction? First of all, what does that mean? What's it mean, Eric?
0.1 repeating.
Right. So that means point 1 when can I stop? 1 when I run out of breath or till infinity, yes? Okay. So it's not 1/10, is it? Because 1/10 is 0.1. So what is it, Eric? It is indeed 1 over 9. Why?
That's what my grade 9 math.
Exactly. Somebody told you the trick and didn't bother telling you why. Why is kind of important. What's bigger? 0.1 or 0.1111111111111? Right. Right. 0.1 repeating is slightly bigger, yes? And since it repeats, it's a rational number. Agreed? And if it's a rational number, we must be able to write it as a fraction, yes?
Yes.
And to write it as a fraction, I must use integers, yes?
Yes.
So I know that it's 1 of something, but it's not 1/10 because that would be 0.1. It's slightly bigger than 1/10, but the denominator still has to be an integer. What is the integer that makes a fraction bigger than 1/10? It is indeed 1/9, because it has to be an integer. And in fractions, a ninth is the next size after a tenth. Everybody with me? Because to keep it integers, I can't put a decimal there. Everybody cool? That's why we use 9 whenever we see a repeater. Okay? We don't use 9, just 9. All right. Now, look at C and tell me if C is the same concept as B.
No.
How many people say yes, it is? Why do you say it's the same concept? Because that 2 is repeating, yes? What's wrong with that assumption?
Because it doesn't say anywhere it repeats. It only says that it continues.
Exactly. Dots mean the fraction continue. The decimal continues.
Get your math, man.
Everybody understand?
At
So,
the end of the day, hard for you.
if you see something like that, no, math is never difficult for me. It's difficult for you people. No matter how easy I make it.
You guys can't go.
What? So, when we see this, half of you made an assumption. Is that assumption valid? It's valid. Can it be proven? No. So the best you can do in some of these situations is make an assumption. And your assumption is, this is 2 over what? 9. Everybody cool? We have no guarantee that the 5,722nd decimal place here isn't a 7. Everybody understand? So sometimes we make an assumption. As long as we can back it up, it's allowable. Everybody with me? Now, look at D and tell me what's really weird about it. The 4 is the only thing that repeats. So if I'm going to make this into a fraction, there's got to be a 9 somewhere, right? So what must the denominator be? It must contain what? It must contain a 9. Can it be just a 9? No, because when we had 1 9, it was only one number repeating. So it can't be that. Okay, so what are some guesses that I could put in there? Christian, what do you think it is? You think it's 99? Let's check. What happens on our calculator if I do, I've already got it right here. Damn, clear. 54 divided by 99.
That's 9.
54 divided by 99. Is it? Look. 0.54. That's not what I have. So 99 can't be right. I've made an X there. So, we still need a 9 down there. What'd you say, Kingston? 19? Okay. Now, is that okay? Yeah, now you're getting warmer. You need to get bigger, don't you? Because tenths, hundredths, thousandths. So your guess is 109, right? No. You can't be wrong. We're guessing. And you're using logic. You know it's got to be bigger because you know we're into hundredths. You know it's got to have a 9. Perfectly legitimate, right? Check. What's 54 divided by 109? No, that's no good. So, no, can't be that. What do you got? 199. 199. Why do you think it's 199? Yeah, no, I said it's got to be over 100, right? Or it's got to have at least some decimal places, right? We can't have only one number in the bottom, or we wouldn't get hundredths, right? What makes you think it might be 90? Christian. 99999 on and on and on. Okay. That would be very similar to 99, right? So 90 is right.
Yeah.
Why? How many numbers repeat? 1. So we need a 9 for repeating numbers, yes? Do any other numbers repeat? No. So what number shows nothing? 0. Everybody happy?
Yeah.
Well, why didn't you stick to your guns, Ash?
That's why I said to start the thing. I said you add a 0 there.
Okay. So is everybody cool with that?
Yeah.
Okay, now, what would go on the top?
54.
But isn't 54 over 90 a rational number? And isn't that just 6 over 10?
Yeah, so you get 0.6.
So you get 0.6, so it can't be 54.
49.
Why 49?
I don't know. I'm just guessing.
You're right, it is 49, but why? That's the right answer. Can any of you see any relationship between 5, 4, and 49?
Oh no. Dang.
Oh, 5 and 4 added. And then you just put 4. 4 is being
What?
4 is being repeated, but you have to add another number.
He said you hit 4 is repeated, so you got 5 and 4.
Aisha. You're so close. Yeah, no, you're so close. It's like you're knocking on the door like Sheldon, but no one's answering. Yeah. Irrational. Irrational. Irrational.
You have 4 and that's repeated, but there's another number, so you add the 2 numbers together.
You're on the right track. It does have to do with that. What we do is we take the 54 and we take out the non-repeating part.
Oh.
Okay, now there's a whole bunch of math to why that works, but it's Friday afternoon, so this is one of the rare times that I'm stopping at what you do and not getting into why.
Oh, come on, now I want to know.
No.
Because of things.
So, what would this be? 0.68. What would that be over? 90. And what would be the numerator?
62.
62. Everybody cool? Everybody cool? Okay. Now, it is 2:03. I want you to, there are 7 numbers there. They are all numbers that you can understand. I want you to tell me, are they natural, whole, integer, rational, or irrational? But wait, you only have to put one letter, right? Because if you're natural, you're everything below that.
Oh, you're natural.
If you're whole, you're everything below that. Well, except for irrational. Sorry. Should have been a line there. Everybody understand? Talk to your neighbor. See if you can figure them all out. Go. Some of these notations you haven't seen before. You have to use your brain.
I don't want to.
I know, it's not fair. School making me think.
Oh, yeah, man.
It's got a lot of nerve.
Ah.
Yeah, because I.
Shouldn't I just fill in a multiple choice test 12 times and get out of here?
14 negative. Bam.
We. Alright. You had to write 7 letters.
Done.
Some of you, a couple of these you're going to have no idea about, and that's fine. You can make a best guess. The first one happens to be one of the more difficult ones. What is it?
Yes, like what's the number or what?
No. Which of these is it?
Irrational.
What?
Rational.
Rational? Irrational.
Because it's
It's a cube root, which means I need 3 numbers that are the same. Are there any 3 numbers that are the same that multiply to 14? No, of course not. What about the root of 25? What's that really? What's it really? 5. Where does that fit? Natural. And then it automatically fits into everything else. What about that guy? Why is he rational? That doesn't repeat. It ends. That guy's rational. What would he be as a fraction? 5 and what?
3, 1.
No! 319754 isn't a number. 5 and what fraction?
300.
No.
319.
319,754 over
A big million.
a million. 319,754 millionths. Millionths. What's D? Frickin' laser beams. What's D?
Integer.
It's an integer? Really?
Oh, man.
Whole number.
Wait.
I don't know. I don't know.
What's the base?
-2.
What does that little number mean?
4 times.
Negative 2
-2.
4 times. What's negative 2 times negative 2? Positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is 16. What's 16? Natural.
I got that right. I see what you did.
What about 9? Natural.
No, now it's
What about F?
Natural.
It's an error.
It actually is I. Not irrational. It's I. Does anybody know what that I stands for? No, it's not an integer. Why do you think it's an integer? Because you think it's negative 2, right?
Is it I for impossible?
What is negative 2 times negative 2? Positive 4. I needed the square root of negative 4. Is there such a thing as the square root of a negative number?
No.
No. That I stands for imaginary.
See, that's a false question.
It's not. Because just like, what was the title of this lesson? The real number system, right? There's a whole nother number system called the imaginary numbers.
Just imagine.
You guys think math's hard with the numbers that you know? Oh yeah. Whole nother system. Imaginary numbers.
Do we learn it this year?
No. You won't touch it till very high level physics and math. So most of you will never ever deal with them.
good.
But, last one. Can you tell me emphatically?
It's rational. I don't know. Oh no, it's rational.
What must I do with G?
Assume.
I can only assume. As it looks now, is it rational or irrational? Rational because it's 1, 8, 1, 8, 1, 8. So it appears rational. But how do we know that the 723rd decimal place isn't a 4?
We don't.
You don't know it. Does everybody understand? All right. Now, this is your homework, page 87. The answer right there, please notice how little work it is.
Oh wow.
All right? While you're doing that, I'm going to give out your tests. We're going to go over the last couple of questions. Because we only got to the trees. Did we get to the trees?
I think we were at the tree.
At the trees?
We're at the trees.
At the broken tree, I think.
We're at the broken.
Oh, right, the broken tree. Yeah, that question makes me cry every year.
Why?
Because it shows that no teenager has an imagination anymore. Because apparently not one of you can draw what a broken tree looks like.
I was thinking.
I shouldn't say not one. That's a horrible generalization, Emma. I
Are you
apologize.
assuming, man?
I am. I am making an ass out of me and Umption by making an assumption. The saying is you make an ass out of you and me, but it's fun when you say I'm making an assumption, because then you can make an ass out of me and Umption. You and Umption. I know you guys give me a hard time, and yet 90% of this class mostly use math, and yet you give me a hard time.
No, B. 4.
It's kind of hurtful, really.
Oh, I can
It's fine.
Yes.
Everybody moves around. Oh, she's way over here today. I know, you guys just move around so I get my exercise. You don't want me to get any fatter than I already am.
Yes.
Thank you. You're doing it for me. I get it. I get it. You guys care that much. Thanks. Thank you very much. No. Connor's not even here.
Should I say thrash? No, because it was games. Number 13.
Chandler Ball. No, it's from the show Friends.
I guess.
Yes.
Wow.
Cheeseburger. What?
What?
Cheeseburger.
Oh, so burger. Number 15.
Write a number that is irrational number, not an integer.
That was you, Seamus.
What?
What the hell? Why are you assuming he's something? I was there.
I only have 3 mistakes in my life.
My mom slipped on ice in 1990 and broke her ankle.
I got the right trig, but the wrong answer.
Right trig, wrong answer. 2.1.
You want one more mark? There you go. See how agreeable and amenable I am?
Yeah, I got 13.
Sorry, buddy. What? How do you know?
I think I did the question wrong.
Nice work.
And read it. I got like 7.
All right.
What did you get for the last
Quickly to the tree question.
one? Explain to you the very last